Good afternoon, everybody. My name is Dr. Neal Frasier, and I'm here today to talk to you a bit about big data and the hype around big data. Has anyone heard of big data in the room before? A couple of people interested in it? Good. So firstly, I'm just going to introduce you to what I do at the university. So I teach at the MGSM, which is our business school across the campus here, and I teach business analytics in there, and I also work in the main university as administrating strategy and information for university. So that's quite a diverse role. Quite a few things I run in there, and a couple of teams I run. So I actually have quite a substantive role around administrating the university, but I also teach over at the MGSM. And my area of interest and expertise is around very large data sets and data warehousing and big data. So we use that term as a term which covers what has been about 20 years of information management. So it's been a long journey along this path to get to what I call data science, but the marketing people in the world call it big data. So on that, I'm just going to take you through some of the hype we're seeing around this space, where it's coming from, and how many areas, I suppose, in Australia which have started to lift their interest into this to actually become a vocational outcome for students. So interestingly, I'll just start off with this is a paper that's just come out from the Australian government, which is the Australian Public Service Big Data Strategy. So they've actually articulated in here is what are the opportunities, the benefits, the vision for Australia. They've also articulated in here a number of long-term initiatives and funding that will come from central government around big data. So this is a pretty serious first piece of, I suppose, long-term thinking that's happening in Australia around what big data might mean for the economy. And we just heard a bit about the economy in the last lecture. This is one area which we have heard about quite a lot, about the growth in the digital economy and moving to an information-based economy. So big data. I'll start off with, obviously it's about computing and computing technology, and it's about the information that is being captured nowadays from all sources of interactions that are going on. Particularly, I should imagine you're all typing away on your phones here, or you're involved in some generating actual data today. All of that is captured and measured and managed and actually analysed mainly by machines these days. So firstly, what is big data? So you might have heard of these three things that they talk about in the big data space, which is the volume, the variety and the velocity, but there are also a couple of other V's as well, which is value and veracity, which is the accuracy of the information. But the important thing about, I suppose, the big data space for me is that a lot of this has been done for a long time. We've been dealing with volume for a long time. I mean, in my previous commercial work, I was for 15 years running large telecommunications data warehouses. So that's pretty much the largest central information systems you'll find in any country, in 3 or 4 countries of the world. So we were building very large systems for a very long time. So volume for me is not particularly different. But what is interesting is the velocity of information. Now, the velocity of information is changing quite rapidly, and I was reading that we now create 2.5 quintillion bytes daily. And on top of that, we generate about 6 trillion gigabytes annually. So there's also 6 million new web pages every day. So you can imagine the velocity of information that's being generated cannot be read by humans anymore. It has to be read by machines. And so that's part of this big data space, is to actually understand what is being generated on the web on a daily basis, or through the mobile space, or through your smartphones. It has to be captured in the communications layer and then interpreted beyond that. So we were, in my industry, and what I was working in, we were doing that for a very long period of time. What changed for us around this space was the variety, the V, the last V. The velocity I've covered, it was speeding up, but the variety changed substantially from the structured form to the unstructured form. And that was when there was a mindset shift in big industries about how you tackle the problem of unstructured and sometimes just semi-structured, which is stuff that you might type in a Google search engine that's kept in a weblog. But the unstructured stuff is the interpretation of what you write in email, and it's natural language processing, it's looking at text engineering, and the sophistication around that space you might be aware is highly advanced now. And teams out of Stanford were pioneering this early, about 10 years ago. So it's quite an interesting space. A lot of the big tech companies have adopted the technologies, have adapted the technologies, and have moved them into very commercial products. And I'll take you through some of the commercial products that you use on a daily basis, which came out of the big data application area. So that's the 3 V's. When you're writing up in terms of a business case in a corporation, you're getting funding to hire data scientists, people that will understand how to manage this complexity, integrate the data sets, and then be able to turn them into value, which is the other V there. So the value side of this is critical. And if you read the Australian Public Service document, you'll see they are talking about the value to the economy in policy making and what they plan to do with the information they integrate. And also they raise in it one of the fundamental questions is, where does the laws around privacy impact us on this? Because a lot of information is being shared, a lot of information is being bought and sold these days, and we have new federal privacy principles coming in next year. So there's a whole legal aspect to this information age which is really important. And so from a business point of view and also from a government point of view, it's an area of interest. So there's a big push on to understand how to make sure that you also protect the rights of the individual as they start exposing their information more to the web. I don't know, I'm sure all of you download apps or put them on your iPhone. Every time you press accept, you will be sharing your contacts list, your location, pretty much an entire set of information which you've just pressed accept on. So apps these days are super smart, and people don't realize they just want the latest app. But what they do is they expose their information to being captured and read by multiple machines, mainly overseas, not in this country. So there's a huge industry in information, which is transacting information and selling information and buying information. And it's part of the economy. People don't realize it, but it is very much part of the economy. So that's the V, so that's where big data has come from. The actual information that's being generated, I'm particularly a big fan of Twitter. I've just seen them going to IPO, so that's interesting. The first time we've seen, they have been a very big supporter, I suppose, of the public space and information. It'd be interesting to see who owns them in the future. I know Apple made a bid to buy them, but I think it's now going to be still held in an open market. But it is the generation of 10 terabytes a day, which is known as the fire hose feed out of Twitter, is a huge source of information around social trends. It's understanding how human behavior is evolving. And what's interesting about Twitter is that people predicted one outcome when they started looking at these trends, but what they're seeing is emerging outcomes which they didn't predict. So human behavior is not as predicted because of the technology that they're using to communicate. So something's happening here which a lot of social anthropologists and people who study this are actually realizing that this is a very, very different world that we're heading towards. The other one is the 6 million pages a day, which is quite spooky. I mean, you imagine 6 million new web pages a day. Some of them are machine-generated pages. So that's the sort of volume we're dealing with. The iPhone was a transcendental moment in the communication industry. It was the moment when I would suggest that we actually started using mobile properly for internet browsing. Before that, people didn't really use the smartphone very much. I was there at the launch of these things in the communication industries, and it was fascinating to see the contract that Apple put up for us to sign. It was a 250-page contract, and the amount of information that they requested from the companies to actually be able to sell that phone was phenomenal. Never seen anything like it. So interesting aspects of what's happening is that communication device, along with the other smartphones, and they released 2 new ones this week, a cheap version and a more expensive version, have dominated this internet browsing. And the internet browsing when you're on a mobile, I'll just explain, is a bit different because it's attached to your SIM. So everything that you do is seen, and it's attached to your unique ID. Before that, the internet was relatively anonymous. In the mobile space, it is not anonymous. It is very clearly easy to track anybody and anything, and then what you type into Google. So it was a very big change in the communications industry when people started using the iPhones predominantly for browsing the web. So that was a big shift in the way that people approach the information space, and particularly unstructured information, because it became easier to identify what people were doing. And as you're aware, governments got interested. So on that, well, I'm just going to take you through a little bit of the hype that's going on around big data. So this is a bit of a West Coast video, which is a company which is, let me just start that up again, which is part of this new wave of Silicon Valley startups that are going on about big data, big data, big data. So this is the hype side of big data. This was last year, I think they released this one. Finish it there. So that's Link Analytics out of West Coast Silicon Valley. Particularly interesting, they said that governments there are better to serve their citizens from this. That is yet to be clarified. The superhuman of the future, they're saying, obviously, is this guy, the data scientist, this person that will be employed by the likes of Google, LinkedIn. They pioneered this work, particularly Amazon and LinkedIn. You probably, if you are connected up to a social media site, you have what's known as a PMYK engine, which is the people you may know engine, which is a recommendation engine, which is based on a big data graph style database, which actually builds out the algorithms that tells you who you're connected to. So they are, they're pretty sophisticated tools, but you'll be touching these tools in a day-to-day basis. And they've been built primarily by these big tech companies out there who have developed the technology to be able to adapt to this new world. This is actually the job adverts on LinkedIn for data scientists in the last 2 or 3 years. It's just been going exponential. A lot of the jobs that people will be heading for will be overseas, and a lot of them will be based in America, I'd imagine. The interest in Australia, there's about 4 big data projects currently running in Sydney with the big telcos and 2 in the big banks. So they are spending a lot of money in this space. They spend 20-30 million a year in actually developing tech to put into this space and employ people. So you'll see data scientist jobs in Sydney as well. So it's an area that really is expanding quite quickly. Where does Macquarie fit into all this? Well, we've been setting up a couple of courses. Firstly, there's the one on the MGSM. We work with one of our partners called SAS, which is a software engineering company. Does statistical software, but also they specialize in some high-performance computing technology, mainly in the cloud. And then that's at the MGSM. The Faculty of Business Economics is setting up the Business Analytics undergraduate program, so they're going after this in the undergraduate space. And in the bottom here, we have the Faculty of Science, which is specializing in the postgraduate space, which is far more about the data scientists. So that's actually setting up things to do where you actually look at natural language processing, machine learning, a little bit more technology based, but actually more focused on around how you take statistics and actually apply it into an actual context around machine-based learning. So it's actually moving, applying some of the things you might learn in Stats 101 and taking it into a IT-based framework. So that's the 3 things that Macquarie is specializing in setting up. I'm happy to take questions on that later on. We're the first to do postgraduate in data science. It's a follow-on from what's happening in, say, New York University and a few other universities in the States. And they see there's an opportunity there around what people are interested in learning. And we're doing that with Professor Mark Johnson, who's an expert in natural language processing. I don't know if he's here today, but he's one of our experts in text engineering and natural language processing, amongst other things. So there is a bit of hype, but there's also a bit of reality what we're talking about here. And we certainly sense that the reality is getting the vocational training in place for people to actually understand how to take their skills that they've learned in the base units and actually start applying them into something more commercially contextual. So that's a bit on that. What is the origin of the big data? So this has been going on since about 1980s. It's not new in that space. It's been named as big data, but it has been going on a long time. Where we started with structured analytics, which was business intelligence platforms, forecasting and planning platforms, linking all the information across organizations so that you could actually make insightful decisions, but often you were connecting them all up through what they called data warehouses. So that's been around a long time, that first layer down the bottom. And then we moved into this next space, which is unstructured analytics, text analytics and machine learning. So that starts to go into things like customer satisfaction scores, it's brand satisfaction, brand tracking. It starts to blend in with the world of surveys as well, and also just looking at how you handle large amounts of document repositories. So that unstructured analytics is probably the space I'd say most people are most interested in at the moment. And the next one out is the cloud analytics, which is nowadays you can get huge amounts of information from online cloud providers. There are thousands of startups out there who take the Twitter feed or take the social media, or take the Facebook data and put levels of analytics around it to interpret brand sentiment or topics that are trending. So there's a huge amount of cloud analytic companies that have started up, and they're interested in what's happening in the social media and the web analytics space. And then the top layer, which is probably the most interesting, was the push around Government 2.0, which is the opening up of the government data sets, which came out of pretty much Tim Berners-Lee, who was one of the founders around the web. He pushed this position on, we need to open up our data sets and make them more easy to actually ingest and manage. And so he set up a new protocol for linked open data. And so now we've got datagov.au, we've got GovHack, we've also got the US site and the UK, datagov.uk. So you've got that, the big government organizations opening up their data sets for other people to use for, and it's protected in the sense that it's not down to the individual level, but it is opening up data which other people can use for interpretation and analysis. So if you go to those sites, you'll see big open data sets that are now released. So linked open data was part of the movement because it changed the thinking about how we manage information on the web. And it's allowing data to be exchanged between machines much easier. And then actually displayed between websites much easier, so you can link to sites easier. So that is actually fundamental to the building principles under Wikipedia. If you go under there, you'll find Dpedia, which is the database that's underneath supporting it, and that actually is all based on the linked open data movement. So there's a bit of a background in terms of the movement of where big data came from, and now it's been clustered up into this overall, I'm not sure it's the greatest name. It has ramifications around big tobacco and other things, but it's like big data is what it's been called for in the market. I prefer to call it data science. This is the number of publications that are going on. So since about 1970 was the first time big data got mentioned in the academic literature, and it was to do, I'm pretty sure, to do with oceanography. So you go back a long way. This has been in the papers in the academic world for quite some time. Nowadays, it tends to be in the computer science journals, and the publication rate, as you can see, has been picking up rapidly. So it's cross-disciplinary. It comes out of, sometimes it's out of faculty of arts type work or faculty of science type work, or it might be, it's a range of disciplines that you'll find the word big data appearing in the academic literature. So there's quite a lot of research that's happening too. So instead of just the areas I'm just going to show you which are interesting from the really big data sets, the really big data sets, now this is going to take you on to what is out there at the moment, and you can go to these websites. Gephi.org is a famous data set. It's a Twitter data set that's now actually been taken down from the web, but it was used by researchers up until I think about 2008 to study Twitter. So it was a public open data set. You could go and download it and analyze it. And what this is showing is a social scale. This is a 24 gigabyte graph. So this is what's called a graph database visualized, and it's something which you have to, so you can actually manipulate the entire graph in itself. And it's got 1 billion vertices, 1 billion edges there, 100 billion edges. So it's a massively large data set. And they use it for looking at emerging trends. And they studied social context around it. So that's a very famous data set that came out of the big data world. The next one up is 10 times bigger than this. And this one is known as the opti.org data set, which is the entire internet visualized. So that bright spot at the top is China, behind the Great Firewall of China. But obviously the main cluster there is America, and down here is Europe. So there's a visualization here of the entire internet that was done by opti.org, and that's still an evolving project. So that's 50 billion vertices, that's a bit bigger. So you're going up by a factor of 10 there. And then the interesting one, to do that visualization, you actually need a supercomputer like the Titan Cray or the IBM Sequoia. So there's a scale of computing power that is required to do this sort of work. The third one is just very interesting, which was 100 times bigger. This is our brain. So this is the neural connections on the brain, and there is not a computer system in the world today that can visualize this. So we do not have the computing technology to do this. So that's not the IBM Sequoia or the Titan Cray cannot do this. The only solution that could probably visualize this in the future would be something in the cloud-based technology, an infrastructure that is massively scalable. And so probably in 4 or 5 years' time, they'll be able to visualize the brain properly. And I don't know if you remember when Obama, he actually, we're going to do the brain project next after the genome project. Well, this was why, because it's actually driving a lot of computing technology forward, because the visualization of this is particularly difficult. So that's the 100 times bigger than the internet. Quite interesting. It's we're still not, the internet's not quite as smart as what we might think. So that's the really big data sets that we hear about. And the other ones, I think, obviously, are things like what the square kilometer array might produce, or some of the astronomy areas. They produce vast data sets in petabytes and stuff. So the technology they use for analyzing this is very different. That's what I just like to articulate. And the database technology is particularly different. The last thing I'll just take you through is the big data applications, which, as you are probably aware, in big data applications, we've got a variety of things going on. So the most commonly studied areas in big data are brand tracking. So brand streams, so that top one, the Coke can. If your brand is impacted on the social media space, you will see your stock price being traded down by machines. So there have been very classic studies on this, because the high velocity trading systems watch where the trends around your brand is impacted. So if you're having a lot of negative sentiment, like Nestle did, or another one of these companies did, because there's a milk powder scandal or whatever it might be, or if this scandal, your share price will be machine traded down in an hour or so by sentiment tracking systems linked to brands. So there's a very big commercial context to what's going on. Celebrity, I read somewhere that Justin Bieber had something like 75 million followers or something crazy on Twitter. Anyway, he has a serious big data problem if he's got 75 million tweeters and people following him. So celebrities use this information obviously to study whether or not they're being popular with what they're saying or unpopular, or they actually need to intervene, or they may need to start doing some ghostwriting on Twitter or something. But the celebrities do need this information to be tracked. Politics is quite an obvious one. You probably, when the election in America went on, I won't say the Australian election, but the American election, the quants predicted every single state. We're just about to finish up. Okay. So I would go on, but these are the areas, and I can talk to more of these if you want to later, but there's a whole lot of areas. The ones which are most interesting are coming up, which is the Smart City, which is an IBM initiative, and the Smart Policing Force, which is about how you actually predict crime and how you predict how you do stuff around a city. And those two areas are particularly new, but being pushed very heavily, and you'll hear quite a bit about that. I'm not going to go through every single one of them. We have some big data on our site, which we look at. We developed some, I won't go through every single one of these, but we have a number of data sets on site, including developing our strategy data set from it. This is also a dissertation browser showing where research comes from around a university. So those are the kind of big data sets you deal with. And I think that is it. So.